All right, let's see what's going on here. Hey. Oh.
Hello?
Hey, Gamal, how's it going?
Yeah, good, yeah, how are you?
Oh, good, 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 good. Um, all right.
So, thank you.
Yep. By the way, just so you know,
Okay.
I'm uh, I'm starting to kind of record and stream these calls just for others in the group in case it's useful for them to kind of understand what's going on. But it's
Yeah,
just
yeah,
yeah,
yeah, yeah, it's fine.
cool,
Okay.
awesome. All right. So what's the
So,
latest? Yeah.
what I did till now,
Hmm.
like like I told you, I pick a message from here and try to print engineering how this message is being called.
Mm-hmm.
Okay.
Mm-hmm.
So, I started with this one of the return type.
Mm.
Okay. And as you can see here, this one relates to the return type.
Mm-hmm. So
It's
wait.
called here in the check function definition.
Yeah, yeah. So this message registry, what's the message registry? I guess is that the registry of error messages or?
Message registry. I guess it is this
Yeah, it's probably
this
yeah. Okay, yeah. It's probably all the
here
errors. Yeah.
that have all the messages.
Right. 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 Right.
No, not
Cool.
all the errors. There are some errors not here.
Yeah. Yeah. I could imagine.
There are all the constant like the
Mm-hmm.
errors, constant errors. I guess
Mm-hmm.
there are another errors here in the checker.
Yeah. Yeah. In the passes
Uh,
themselves, they'll
like
have it. Yeah.
immediately.
Yeah. Yeah. Yeah.
So they don't have like a unique way
Mm-hmm.
to have the error message. Okay.
Yeah. Okay. Go ahead though.
Okay. So here in the checker, this is the error message. So if you go up and look at this, mm, so this function is called the check function definition. So in this function, it checks the function itself.
Mm-hmm.
Okay. The function definition itself is the function calls, and I scanned through it like first, first, and I found there are something called return types. I
Mm-hmm.
think
Okay. Does it use the same type info stuff we
so.
were looking at last time?
No.
Okay.
What type of info? No,
Remember
no, no.
type. Okay.
It doesn't use it. Yeah, yeah.
Okay. Yeah. Yeah.
It doesn't use it. It's here in this here.
Mm.
Like you can see, there are like a list of return types, and it uses like a stack. Okay,
Okay. And what's the
like a
actual
stack.
yeah what's the actual types of like type and ret type? What are those objects?
So I tried to reverse engineer these types on how it got generated.
Is it actually the
Okay,
types from? Oh yeah, but go ahead. Yeah.
so I tried to like reverse engineering it a little bit, but it
Mm.
was like too difficult to be honest. So what I did is like I picked a simpler message, like this
Oh.
one,
Mm.
uh, this one. As you can see here, I created a variable, and the variable was string, and I add to it. Originally it was like add zero to it. Okay,
Mm.
so this is the simplest type check
Yeah.
can be done.
Yeah. Yeah. Yeah.
Okay,
Yeah. Totally.
so
Mm-hmm.
when you do this, you'll see the incompatible types and assignments.
Mm-hmm.
Okay,
Mm-hmm.
so I reverse engineered this
Mm-hmm.
as this will be like much easier.
Yeah. Yeah.
So
Yeah. Makes sense.
I go to this hearing checker. Mm, there is like a visit assignment statement. So what happens in the checker originally,
Mm.
like in the state, we can say yeah, in the state, we can go a little bit further here in type check first. Okay,
Mm.
so not all the types or the type errors are reported here in the semantic analysis for SFT.
Okay.
Okay,
Okay.
so as you can see here, I print types not here yet, and this printing is before the types, is after
Mm.
the types. I mean,
Yeah, yeah.
or after the method.
So it might be happening in
So
process graph, right?
yeah.
Okay.
So what happens in process graph? I skimmed through it a little bit, and I saw like I didn't catch something from here as process graph for recall like many functions.
Sure, sure.
So
Yeah, yeah. Well, quick question though.
I
Quick question. So,
okay.
if you were to comment out that SEC semantic analyzer at the end of the type check pass, would the tests pass? Would like
Uh,
because it looks like oh, I mean we could look at it later. I was just yeah. Okay.
will pass.
Yeah, yeah, yeah. Okay. All right. Let's
So
yeah.
so
Go
what
ahead.
happens that
Hmm.
not all the type checking are being done in process graph, and not all of them are being done here.
Mm-hmm. Yeah, because why? Because
So
you didn't get the type error for the count equal string equals 0. Like why
no,
do
no,
you?
I get all the count errors here, but I remember that when we tried this on like the game, this is RPG game,
Hmm.
and when we first analyzed this, when I created the task,
Mm-hmm.
uh, we needed this function.
Mm-hmm. Mm-hmm. Okay.
Okay,
Yeah, yeah.
I can't remember. We can like comment it for now and
Mm.
like check what is the difference.
Yeah, we could check
But
later. We could check later. That's just a side
yeah,
question. I was just wondering. So what would make sense to me the way I'm processing that is there's certain code based configurations for which some pass of the type checker is needed to like accommodate that situation, right? So like if you have
yeah,
imports of imports or some complicated dependency graph, like there's some
yeah,
future pass of Mypy that'll actually catch those errors. And so, for the simple example, those are easy errors to catch, so you're catching it right away in an early pass. But maybe with a more complex code base like the game, like you need some of these,
yeah,
SCC. I looked into it. I forget what it was called, but it's some kind of something component something I forget, but yeah, so like yeah, anyway, so I think that's what's going on, but anyway, yeah, go ahead. Right, so basically you found a
so
yeah, yeah, continue, yeah,
after checking process graph, it calls like many stuff, so I didn't like go all over again
sure,
because it takes much time. So what I did is like here in the checker
mm-hmm,
itself, I went to the checker object,
mm-hmm,
and I searched where it's being used. Okay, so as you can see here, many
okay,
types of so you will see like
so this is a pass,
checker.
right? Because it's a node visitor, um
Yeah,
and I guess does it go over the whole module, like it starts at module and goes through the whole file, or I guess I think the biggest hint will be like when it does its type check. Well, this is the
yeah.
checker, right? Because
This
there's
is
it could be
this
different
is
than
what
inference, but go ahead. Yeah.
yeah. No, the type inference is being done here also. There are two passes for the type checker, so like not two passes. There like type check first one.
Mhm.
In the type check first one, it
Mhm.
will do some type checks, and there are some holes in the types. It will be like assigned to like I don't recall the word itself, but something like hole. You can call it like a hole. And there is a type pass 2. Okay, so in the type pass 2, it will iterate on all the modules to make sure that all the holes are gone.
Mhm. Mhm.
Okay, so the checker pass itself, it will use like expression check and memory check. These checks are being used here in the checker in the type checker itself.
Okay.
Okay,
Okay.
so I searched about the type checker and I can find it here. Like mm, all these are not like it's not creating an object on it. The only place it creates an object here in the build. So we're in the build in the state itself. Okay.
Mm-hmm. Mm-hmm.
So every state or every module in
Yep.
MyPy
Yep.
have like type checker.
Mm-hmm.
Okay. So where is this type checker being called? Uh, okay. So the default of this type checker is none, and there is like a singleton function to create it.
Mm-hmm.
Okay. So it will always call type checker. If it's not created, it will be created. Okay. And there is the two passes, type check first pass, and I guess there was like type check second pass.
Yeah. Okay.
Okay. Okay. So I went through type check first pass, and we are back to the type checker. Okay.
Mm-hmm.
So here in the type checker, it like do some stuff, and by the end it will call the accept. Okay.
Mm-hmm. Mm-hmm.
So the accept will call the visitor. At the end, it will call the visitor function
Mm-hmm.
of this uh, pass. Okay. So I added like this assignment, the simple assignment I showed to you.
Yep.
Okay.
Mm-hmm.
And uh, retrace the code like this visit assignment. And from here I started to add the printings. Okay.
Yep. Yep.
So
Yep. Yep.
here we have like print here. So the error. So these printings are related to this line 9.
Mm-hmm.
Okay, count string
Mm-hmm.
equals 0 and 0 is the integer and count should be string. Okay.
Okay. Let me see
So
the.
I
Okay.
started to,
Let me see this as so. Oh, no, just go back. Yeah, to where your print is. Yeah. So this is a visit assignment statement inside of the
yeah.
type checker. So it's visiting that node. That's a MyPy node, and then it's doing some kind of analysis. Okay. All right. Go ahead.
Yeah. It will do some kind of analysis as you said, and by the end it will call like check assignment. And then the code it's being called. Yeah, I guess this.
Yeah, that's fine. But let's look at some of the data, right? So S is the only thing that's passed into this. So I guess it's gonna
Mm,
S has a dot type, right? I don't know what that is,
so
but
what is first?
SR
Check
value.
assignment type.
So could you go to like assignment statement? Just let's look at that object. Like, what is the class assignments? What is S? Is that a MyPy node? That's a MyPy node, right?
Mm,
No. Yeah. So scroll up. I'm looking at line, the assignment statement
yes.
object. Yeah, like that. That's probably a MyPy node,
So
right?
yeah.
So MyPy nodes have basically is alias def, I guess. You just go to that node real quick. Just go to the assignment statement node definition.
Okay. So
Okay. Here's the slots. Interesting. So it has the L value to R value, of course. It has a type. So that's good. What is type? Let's go to type is MyPy types type. Let's go there real quick.
mm,
Okay. So the nodes have types and it has slots, can be true, can be false. That's a silly set of slots. What
yeah.
else does it have? It has nodes context. Okay, well, it doesn't have any other like fields. Then can be true, can be
No.
false. What the fuck?
No.
Uh,
Basically, I didn't go through this direction.
Go wait. Yeah, go down just a little bit, real quick. Scroll down a little bit. Uh, setter can be true. What the fuck is a type? What is this object? Can be true, can be false. A type could be true, could be false. That makes sense. Cannot serialize blah. Oh, that's serialized. Okay. It's a context. I mean, this is a base class of. Maybe they just create. It's possible they just create unique objects for each type, and then reuse those objects, and they don't necessarily need to save anything for the type. That could work. You kind of they could just use a unique identifier for the type, right? When they're type checking, it doesn't actually matter what the actual type is as long as they can uniquely identify the type. I guess.
Yeah.
So maybe they just instantiate an object for each unique type, and then they just reuse that object throughout. That's possible. Can be true, can be
Yeah.
false. What does it mean to be can be false but not can be true? I guess none. Can only be false. Falsy. All right, whatever. Oh, value of these can the default lazy init 0. Oh, 0, 1. Okay.
Yeah, I guess you are searching for about this. Can be true and can be false. Whether the value of the expression
It can be
be
true
true
or
or
it can be
false
false.
in a Boolean context.
They're useful when inferring the type of
There
logic
are,
expressions x and y. Okay. All right, that's helpful. Man, I gotta do this comment game. Like these comments are super helpful for this like random stuff that makes no sense. All right. Um, let's
okay.
think.
So back to what
Yeah,
I
go ahead.
was
Go ahead.
saying.
Yeah.
So here in check assignment, I started to like add these friends. So friends here too. Let me search about this. Okay, so I guess the first one was like visit assignment, and in the visit assignment we call check assignment. So here in check assignment, uh, so I was started I from here I started to like print the L value.
Yeah.
What I did is like I started to add all these friends until I went to like here six check simple assignment, and in this check simple assignment I started to like print all the types.
All
So
right.
I
Let me.
found that the types are here, the
Yeah.
types with here in the check simple assignment.
Oh,
So I
let's.
started to go back.
Well, let's go there. Let's
Search
go.
for
Let's go to here 6.
I guess we can go here
Oh yeah,
to
here
here
3. Yeah.
three.
3.0. Yeah, that's fine.
So in this one, the L
Oh,
value, the L
wait.
value is a string.
The L
That's all.
value of inferred self check L value. So it's checking the L value. Um,
Yeah,
so the L value
I
is
guess
another
I guess
node.
it's
Go to check L value.
let me check.
So L value takes in. Let me see the input. It takes in a L value. What is L value is a type? Okay, cool. Whatever. It's an expression. All right. What?
Yeah.
That's okay. Cool. And then I guess that makes sense. It makes sense. It's an expression. So I'm thinking. Okay. Let's assume it's member. So check L value.
I guess it goes to like a expression checker.
Where does L value type? L value type on that member expression. If it's a member expression, okay. So this is I'm gonna assume that means it's a class. It's like just an expression
Yeah.
inside of a class. So could you shift click analyze ordinary member? I mean, yeah, like go there if you can.
You can do this one.
Yeah. Scroll down. I'm just trying to see what. Okay, so what it returns. Member type equals analyze member access. Module symbol table. Return member type. Analyze member access. E.name. Man, I feel like everybody should use kwargs all the time. Like it just makes code way more readable.
Yeah.
Anyway, analyze member value. Could you just hover over it so we can see the parameters? Okay, it's name. Okay. So there's
main
so
type.
they do have arg only parameters. Why do people use that? Why don't they allow quarks? Anyway, whatever. Is They have the name. The second variable is the type. So let's scroll up and find the original type. Original type is self.accept. Let's look at this accept thing because that must return a
So yeah,
type. I see. So okay, it doesn't actually. Well, okay. Let's see. Type equals visit call. Hold on. Type equals node accept. Okay, so I think accept is where the types are resolved. I don't know why they don't call it.
accept in the accept is like is here, and I guess in the expression it will call
Yeah, yeah.
like the visit, the visit,
Well,
the visit function.
yeah. Ultimately, we just I guess at the end of the day we just want to know where those types are stored. Like it looks like it's stored on the node. So after look, if you have a MyPy AST, after it's done all of its checking and everything, I think the MyPy AST node has a type and on it, doesn't it? Because when you went to the assignment had a type, right?
Yeah,
But it's I don't know how to resolve from that type to the actual like.
yeah, I got that. So,
So I mean, you're getting a string there.
okay,
Me.
so
Go ahead.
if recently at the beginning we have the MyPy AST
Hmm.
here
Mm-hmm.
golden tree, and we assign it. So this tree, this the AST,
Mm-hmm.
uh, I guess it will change in this variable. So it will not copy it or do something like this. So we can do something like print graph, or we can print all the graph. So each graph that we can.
It's a big graph. So each state is a module, right? That's a lot of modules. Are those the built-in stuff? Why would I have so many modules?
Yeah,
Must be the built-ins.
yeah.
Yeah, it's subprocess import limp. Yeah, yeah, yeah. Those are built-ins. Hmm.
Yeah, patterns.
Yeah.
So we can go
Um.
like so this is a state. Check the state. We can okay. The tree is like the MyPy file.
Yep.
Okay. Okay, so I would search on this. Yeah, I would search how to like iterate over the AST, the MyPy AST.
Yeah. 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 I mean, I think it's. Yeah, I mean, they have a type. They have that weird type though with the is truthy or is falsy or whatever. Um, and then you found this built-in string. So it's possible. I don't know. I mean, when it's resolving the types, like it's grabbing the built-in string. I just don't know why it wouldn't attach that to the node if there's a type object, right? Like, so if you could go to here three, like here three is deep in the code, right? But
Yeah.
I think we kind of went deeper than we needed to go. Like, let's go to here three again, and then here we got check. We got the L value type,
So
cool. But this is in assignment. All right,
okay,
so
so can
yeah,
you print uh,
L value.
print
So I think L value is just the left
code?
side. Okay, so
So in here too, L value here is
yeah,
like
is the name expression.
the
That makes
name
sense.
expression.
Mm-hmm. And then the R value is probably what's on
So
the right of the assignment, right? So the R value should be
it will
0.
be like an,
R
I guess
value
it
should
will
be
be
some
like an
kind of
expression,
literal. Yeah,
literal expression. Yeah.
exactly. Let's see. Oh, the R value is a op plus and then named
No,
expression. What?
you are here.
Oh, I see.
You are here.
Yeah, it's an int expression. Cool. Okay, so that's what I would expect. So when it gets the L value type, let's look at how because it gets it from check
So
L value. It
check
doesn't,
L value.
it,
So here it check
yeah,
L value.
no. In our case, it's a named expression, right? So L value type equals expression checker accept. So just go to expression checker accept. Well, because it's probably doing the else case, right?
Yeah.
Um,
So the expression value is
yeah, so that's any expression type node, and then it's grabbing the type from, let's see, this returns the type equals visit call. It just goes into this crazy check
visit.
store
Yeah.
type.
All this. So you can get it like that. It was called int expression.
Yeah, yeah, true. Yeah,
Okay.
okay.
So here in the expression, so I guess visit int expression. By the end, it will call this self literal expression type, and I guess here it will build like this literal
Hmm.
view,
Wait, hold on. What?
and
This is
the
expression checker.
it,
Okay.
yeah, this
Why wouldn't it say that?
not the checker itself, it's expression
Expression
checker.
checker, yeah. Let's look
So
at in.
for
Yeah,
this,
it just returns
how
it.
it
Why would it?
works?
This is so slow though. Like I actually think I don't know if this implement. I don't know if Mypy is just like super inefficient, but if you need to it look. So here's what I'm thinking. I'm thinking that dynamically it'll look up the type. It seems like it's doing a lookup of the type every time, and it's not storing it in the ASD. Um,
We can change this maybe like
but let's look at infer on e dot value, I guess.
we can
Okay.
maybe we can go to
Yeah.
name expression. I need to know how to get how to know the type of the name expression. So for an int expression, I guess it simply calls like if it's like an int expression node, so the type is int expression. Okay,
Mhm.
so
Mhm.
it simply returns. This is goes the same with like if we have like string expression, so it's string
Sure.
expression.
Yeah. It's kind of
For
like
the name expression, how it
oh,
works,
true. It might do a
right?
different. Oh, yeah. It might make a different approach.
So this is
It,
like name
it,
expression.
it yeah.
What is this extract ref expression name? Recursive extract or no reference to a reference.
That could be like some kind of update of the symbol table or something. Um, but it seems like the result is what's returned. E is
Yeah,
the yeah. Let's see. Yeah, that's true. Print R. Yeah.
yeah, that. You can do like
Well, that's interesting. I see a lot of 3.1.1s.
yeah, yeah. Oh, it's not printing.
Oh, it's printing, right? Like there was a number of them. The 3.1.1s. I think that's for the function. That's the function signature, right? That's
Wait,
a
wait,
like
not this one,
factorial.
not
Yeah.
this one. So we are looking.
Oh, I see.
Uh,
You're looking for.
so it's yeah, it's not printed. So maybe it's printed like Why it's not printed? I thought it
I
will be
know,
printed
I
here.
know. I see what you mean. Yeah, I
So
see. Because it's in the this is that was a named expression, visit named expression, and this is a and it was a named expression. Yeah. Wait, hold on.
yeah,
Yeah, it should print. I think.
it should be full. Yeah. So this is a named
Mm-hmm.
expression.
Yeah, yeah.
Okay.
All right. Well,
What I'm doing is like to go back again.
no, no. I mean, it's okay. Like we don't have to have that named expression. I think ultimately we just want to see. I guess look, there's two assumptions. I have one assumption. My
Okay.
assumption is types are types are stored in either the symbol table or in the AST itself as attached to the node.
Okay.
Let me see. So that's my assumption. It could be in both. Uh, so I don't I right because like when you look at um, it'll say like built-in string, right? Built-in string.
Yeah.
I'm thinking built-in string throughout the check is stored somewhere in the AST or the symbol table. So so I'm just trying to find a variable that's I guess I'm thinking out loud, right? I'm trying to find a variable that is in the AST or the symbol table that is that type. So I guess the assumption is there built-ins.string is living somewhere either in the AST or the symbol table.
Okay.
So I guess that's what we're trying to find. So it's fine for us to look here because we do print it somewhere. And I guess the key question is where is it attached? So there's this narrow type from binder. Go into narrow type from binder. What is a binder? Type binder? Type binder sounds promising. What is a binder? Huh? Okay, okay, overload, overload.
Not a typo.
Using information in conditional type binder. Oh, okay, this is the type checking. This is a type checking construct. So, um, hold on. So when it's done, so basically after we do this, right? Like, wouldn't we store it somewhere? All right. So go back to the type checker. Let's see what it does with the type after it returns, right? So like if you go back to,
2.1.
I think okay. So one of the interesting places where we should put a bookmark is your check assignment, right? We got to have a bookmark there.
Yeah.
And then I think
Okay.
what we should do from check assignment, where you're printing here 3.1, let's say, is
Yeah.
follow where that type goes. After it's resolved, like what happens. I mean, after it's accepted. You see, I don't like the term accept because I don't know what the hell that truly means, right? Like, maybe we should ask
I think
ChatGPT.
acceptor is related to the visitor then pattern itself. As if you search it for like visitor then pattern, all the implementations are using the word accept.
Yeah, but accept returns a
So
type, right?
um,
I mean, in this case, I mean, which is fine. Yeah,
I, okay, yeah, I guess it assumes that all the visitor functions will return a type. So
yeah,
when you call accept, it will in return call this. Maybe I don't know.
yeah. No, that could be it. I mean, it's possible this thing is designed. This Mypy is designed. So this assumption that we have, right? The assumption of there must be a type stored either in the symbol table or the ASC. If that assumption is
Yeah,
wrong, it would mean that MyPy does everything live. You know what I mean? So
yeah,
it's an algorithm that will resolve and check as it goes without saving any data. And if that's the
yeah,
case, that's actually okay because it could be the case. Honestly, it could be the case that what we really need to do is overload accept, or like what do we call it when we when we put it in Mypy AST build, it's kind of like we're
Mm.
we're overriding,
We're
right?
overloading, yeah.
Yeah, we're
Yeah.
overloading accept.
Overriding, yeah.
And so maybe we just
Overriding,
override accept in such a way that
yeah.
we dynamically resolve what node it is and then store the type in that node, right? That might be the solution. If our assumption is wrong, that's the solution. Um, this would be wonderful if ChatGPT was smart enough for me to ask that assumption and see what it says. Let's see what ChatGPT thinks. So I'll just bring up a browser. I'll share my screen. Let's go on a little bit of a ChatGPT journey. All right, hold on. Let's do this. Let me share with you. Where's the Zoom? I mean, I have too many screens. Oh, here we go. Nope, that's not you. Where? Oh, it's right here. Duh. Okay. Hold on. All right. Let's share, and then I'll share that. Let me know if you can see that. Okay. All right, ChatGPT, help us out here. Oh, jeez. Okay. So, does Mypy store types it resolves in its Mypy AST or symbol table? Come on, ChatGPT, hit me up. Okay, good. It does store the types it resolves in internal structures, including the AST and the symbol table. Remember, this could be all hallucinations. These components are crucial for Mypy's type checking. Yeah, exactly. For Mypy's type checking process. Abstract tree symbol table. The symbol table is another critical. Yeah, we know what that stuff is. Okay, cool. All right, so it says yes. It's giving us a long answer. It says yes. Okay, cool. Do you know where in Mypy this storing, let's call it storing, where in Mypy's code base this storing occurs? Come on, give me something good. Symbol table across several modules, AST nodes. Okay, all right, let's see. I know this. Type information is often attached to these nodes attributes. Yes, I'm aware. The thing about the type, seminal, yeah, we looked at all this. Type checking logic, where the types are verified. It's primarily found in the module, which was AST nodes, and applies the type rules to ensure consistency and correctness of the types throughout the code. As the type checker, process utilizes. Okay, wait, hold on. Let me ask. Let's really push this ChatGPT. Geez, I don't know if it'll be able to answer this. After all types are checked and verified, where would be the best place to look up the final types of the AST nodes? Okay, good. Come on, ChatGPT, please. Checked and verified. The final types of AST nodes are directly attached to the nodes themselves. This means you can look up the final types. Okay, I know there's this types thing. Yep. Var.type, blah, blah, blah. All right, cool. The thing is, when we looked at the type, it only had Man, I don't need this long answer. Using type maps? Wait. It says the best places to access this type information depend on what you want to achieve and at which point of the Mypy code base you're working or extending. However, here are a few general points. Since the type information is attached to it, you can directly access the types if you have. For example, if you have these things that contains this resolved type, similar functions, class definitions have attributes. Yeah, I know this. So class diff has info, vars have type. Honestly, this vars, we should really just override var, because like that's what we need now. Like that's actually the most important thing that we need now. Um, but the thing
Can
is,
you check the second item here, like through type checker, as it proposed, like we need to like create a new plugin. This plugin will run after the type checker, and in this plugin you can like create the types of the nodes.
yeah, and then it's actually very easy. Yeah, I mean, we can actually start building it based on hypothesis, because our ASD already has the MyPy nodes attached. I, if I remember correctly, it has the MyPy nodes attached
Yeah,
to the AST nodes, so we could actually walk the tree, find the var nodes, and then like print the type object. But that type object, well, I mean, we could try this now. Just print one of the type objects, right? Like basically the mypy dot type object. Uh,
yeah.
the
So you can
only
start from here.
store.
So here is my file. So
Yup.
so do you know how to get the ASP from my file?
Yeah. So yeah, of course, I could talk through it. Let me just see what this says real quick. Is the base class of all type classes, and does indeed have methods like blah, whatever. But oh, I see. So there's I see. Hold on, that we were looking at the base class. We weren't looking at the. I guess there's probably a types. There's probably a types module we should look at that has all the different type objects that could be attached to the node. Okay, dude, I think this is Chat GPT for the win, dude. I think it's giving us
Yeah.
the key insight here. Okay, so all right,
Okay. So I can check types, uh, like ChatGPT, like tools.
yeah. So all right. Well, look, I think I'm pretty excited, right? Because based on our code walkthrough and whatever ChatGPT says, which makes sense, which checks out given what we've seen in the code. I think we can actually just do a post. We should create a pass. This is how I would do it. I don't know how much time you have. If you have time to work on this now, I'm around. So yeah, so I can, yeah.
Like
Because what I would do is I would create a pass. We could do this together now if you want and just have fun with it. So like hold on. Let me share my screen, and then maybe we could hack this out super quick, cuz I know it'll probably be quicker. I mean, we'll probably get there quicker, or I could get us started. And then you can just go from there. So let me I'll just share my code here. Hold on. My code screen. Let's see. Where is it? This one. Let me know if you could see that. All right.
yeah, I can see.
Okay. If you could read, is the text too small? Is it too small?
No, I can read.
All right. Get check out main. Get pull. Oh, did I push that stuff from last night? Yeah, I did. I think I deleted that branch. Okay. Okay, so let me just do a jack clean. All right. So basically what I'll do is after our type check pass, so our type check pass is, I'll just use two kind of screens for this. So this is our type check pass. I'm going to duplicate this pass real quick, and then I'll have, let's call it fuse type info pass. It's a beautiful name. So we'll have this fuse type info pass. And actually, I'm going to do this in a more fun way. So what I'll do is, it's fuse type info pass, right? So what we'll do is, do I need to do anything else before starting to run stuff? Okay. We actually don't need most of this stuff, but okay, let's just get rid of all of this. I'll just get rid of all of this, and then we'll just have enter node, exit node, right? So enter node. Is it going to ChatGPT fill this for me? Let me just go to, I'll just bring up my pass, my IR pass, our general IR pass stuff so I can remember the interface. So it's enter node, any AST node. Thank you very much. And then what we're going to do is, I'm just going to, well, we'll do super. Well, we don't really need to do super here. But I'll just add it. It's fine. Okay, so we'll do super that.
So you will like iterate on.
Yeah.
You will iterate on
Every.
AST, and from it you get
Yep, exactly.
the Mypy.
Yep. What I'll do is I'll print the node dot class dot name and the length, because I'm just gonna sanity check stuff right now, right? So I'm just going to see how many Mypy nodes are attached to each node of the tree. So let me think. And this will need to be like a type check pass, so I'll have to do a check. Anyway, so it'll be the length of the node dot gen dot Mypy AST. Yeah, that's it. Okay, very simple. Very simple. All right, good. So we'll do that. And then what I have to do is I'm going to create a test for this in tests. So we'll just take type check pass, duplicate the test file. We'll create test type info pass. And then we'll just delete, I'll just call this test. Wait. Test fuse type info. Okay, so test. Put a test before it, and then we're gonna do a let's say, let me just update the schedules real quick, and I'll just do this statically. So I'll put a from thank you very much, and then so I'm just importing this fuse type info pass. I'll stick it at the end of the typed code gen pass. And so now that'll run whenever I do check. Okay, I think that's it. Actually, I could just do check. I don't even have to do a test. So I'll just keep this test. We'll do the test later, right? So I'll just keep this empty. I'll do it like that for now. We can create that file. So I'll just put that there. We've got our fuse type info pass, very simple. I'll just delete these for now, just for cleanliness. Don't need this at the moment. I'll just comment it out. I don't know why I'm doing this stuff. I'm just being silly. Okay, so let's just type check something. What's the test that you normally use for type checking?
Func.jack.
Oh, func.jack in jacklang tests fixtures. I think it's in here. Yeah. So it's let's do. Let me make sure jack's running. Okay, that's it. And then it's jack check func. Oh wait, it's not in this one. Func.jack, you said?
Yeah.
Oh, you have it in passes. You have it in passes. I see. So that's actually the right place to put it. Compiler passes main tests fixtures. Okay. So func.jack. So jack check func.jack. Okay. So, well, this is interesting. Let's see. Let's see. Semis don't need a. Okay. Let's just. This could be okay. Why does module have 4 Mypy nodes? I have no idea. String has 2. Oh boy. Okay. Import has 6. How could this happen? Let me think. It's the jacklink stuff. Name should have 1. Oh crap. So
what's the name? Name is.
Name is. Yeah, name is like it's like a variable. Really, it's like a variable name. Okay. So it's not a string. But this isn't great because this means. This means that our kind of association between MyPy nodes,
Mypy and Jack.
and Jack nodes probably needs a little bit of work. But what we'll do, let's just do this for now, real quick. All right, so we're printing each one. Let's just do this. If, gosh, node dot class, come on, just do something smart, ChatGPT. Good, that's smart. I call all AI ChatGPT, by the way. It's pretty,
Yeah.
it's pretty hilarious. All right, so if that's name, and length, no, that's not what I wanted. Length, yes, that's close enough. I don't want this. I don't care. Actually, I want to print this. Actually, it was close to what my intent. I want to print that. I just want to make sure that actually what this is checking, right? Let's see. We'll just get this
And the
name.
name itself, you have like an underscore. You need to add an underscore at the end. Yeah, yeah.
Here?
Line 20.
I need to add an underscore? Oh. Pff.
Line 20.
Yeah. All right, so yeah, that's ChatGPT, man. When ChatGPT codes. Okay, well, we've got some stuff. Let's see. Warnings. Let me clean. Because that should have stuff. Huh? Why isn't it printing? If node class equals.
I guess because all the name have like 0. So can you go down a little bit? A name
There was.
that
Oh, I
has
see.
5.
This one has 1. And length
Yeah.
node.gen mypy is to. What the fuck? Uh, how
Yeah, I
is this
guess it's
possible?
correct. So
Yeah.
we have name. And it
Oh,
was
yeah, I missed it. Oh, I should have. Yeah, I didn't. Yeah, so it's correct. Okay, good. So let's just take that one, and then let's look at its type. Ha ha ha. So we don't have to do this. Let's
Can we
look at its
print
type.
okay.
Oh, go ahead. Yeah.
Can we also print the name of the node, the Jack node, and not like its name? I mean like
The value.
variable name.
Sure.
So,
Sure.
yeah,
That's a good idea. Let's also print the variable name. So that would be. This is gonna have a type error, but it's. I think it's like value or something. Yes, it's value. Okay. Yeah, even though the type checker doesn't know it. Okay, maybe it's named expression has no attribute type. Damn it, that's not good. Named expression has no attribute type. Everything kept saying that it has.
Okay, so can you print all the like
So. The hell?
yeah, can you hear me?
Yeah, I can hear you. Go ahead. Oh, I'm sorry. I was just reading this. I was like, what the hell is this? Anyway, go ahead. Yeah.
Yeah, so can you print?
How do I print all the? I know you could do dir, but usually that's too much stuff. How do you get like all the members? I forgot.
I guess look at okay, I can
What? Are you reading the? I'll do it over here. If you're reading that, CD. Okay, let's just do. Oh, whoops. Yeah, I want to get okay. All right, N, right? This is a oh. Some of them might have type guard. What's N? I should print the line number and stuff. Huh. Let's do it like this. Let's print here node.loc and then node.loc. And I'll rerun these because I'm trying to figure out like whoops. Oh no. let's get rid of this for the left side. And then let's keep it for the right side. Okay, let's also look at func.check. Okay, so if we look at, say, count on 6.
Like check, count,
So count on 6. Let's find 6 here. Count on 6. This is 5, 6. Count. So count has...
Does count have...
It has an accept, but that's a function, right? I don't see a type.
I guess it have like this type guard.
Type guard? Well, really we need var nodes, right? Because it said like, I think type isn't on every kind of node. I think var nodes, maybe ChatGPT could help us with this. Like, okay, so what I do next, so this one doesn't have type. What I would do next here, just out of curiosity, is for all of the Mypy nodes we can find in this graph, is any of them var? All right, so let's see. So what is that? What would I do here? What I would do here is, no. For I in node Mypy AST. Sorry, this is it. If I, yes, close, var print. Yeah. No, I don't like this. I don't know what the hell that is. But let's also print node.loc. That's interesting. Come on, give me something. 0. None of them are vars. Okay, so we gotta figure out. Okay, let's see. Let me bring up some more ChatGPT real quick. So I'll share that for you. Because
maybe the vars aren't like aren't get linked correctly.
Yeah. By the way, can you see my screen right now, or is it black?
Is it white for me?
It's white? Okay, hold on. Yeah. All right, so let me do this. Okay, so what I'm going to ask is, where are var nodes stored in Mypy's AST? Is it attached to nodes such as name expression? In Mypy's AST, var nodes represent variables, and they are not directly part of the higher level AST nodes like expressions. Here's how var nodes are typically used and referenced in Mypy. Var nodes, including its name and type, it contains metadata about the variables, such as the var.type. Yes, that's what we want. Named expression, blah. Usage in AST. When a variable is used in the code being type checked, a name expression node is created to represent the usage in the AST. The name expression node then references the var node that represents the declarations. This reference allows Mypy to access the type and other information. So, attachment to other nodes besides nodes are also. So it references the var node.
And where is the var node?
Oh wait. Oh wait, dot node? First of all, that's really weird, but let's try it. So let's do named. No wait, this would be, yeah, it would be that.
I guess you only sharing ChatGPT. Okay.
Oh, I'm only sharing ChatGPT. Okay, hold on. Sorry. For some reason, I'm trying to use this monitor here. It's better for recording, but this monitor, for some reason, doesn't sync. Anyway, you should see it now. Let's see. So what I did is I did if I did this if I class name is named expression. I'm trying to print I.node as per
Is that
ChatGPT's. Hmm?
arguments? Where is argument?
What? Function helper.
Is
Arguments.
CR com? Where,
Oh, oh,
this
oh.
one is in.
We're getting close. There's a funcdef here. Um, this is interesting. I don't know. Like this is fine. We're getting close. So there's rares. So that's great.
But why it not crashing inside my file itself?
Oh, why? Which one?
I guess it's been crashed. There is a crash inside my file.
Oh, inside Mypy, this one? Oh, I don't know. Let's see. It's funcdef objects has no attribute arguments. I don't know why it would be. I mean, is this a property? Is node a property? Because if it's a property, I would expect this, right?
Yeah.
Let me see something. It would be better to do it this way, right? From basically, it would be better to do it as an is instance type thing. So import mypy dot types. Wait, what? Where is var? Nodes, right? Nodes
Yeah, I guess
as
it's
nodes as m nodes. And then what we'll do is if is instance. Oh yeah, beautiful. Let's see what node is. Node. And let me just control click that. Node is ref expression. Node is symbol table. Oh, but why would I get this error? You're right. This error is kind of like nothing weird from us. Is it calling an accept? The thing is, I would expect to get an error that nodes isn't an attribute. This is a very strange error to get,
Yeah,
right?
yeah.
Because if it's not a property and it's not an attribute, what the hell? Let's do a jack clean. Let's see.
Okay, you can like. mm,
Hmm.
maybe- I, I,
Helper. Accept. Let's see what's actually executing.
mm,
There's a traversal? Why is anything traversing? All right. So in the stack trace, huh? Wait a second. I'm just going to try something. I'm just going to do pass because is it the print node or did we miss something? No. Weird. So we're just printing i.node and that's creating the issue. That's very interesting. That's very weird. But there what? Is there like on does function def have a on access or something? You know, like sometimes you have these
yeah,
yeah,
yeah.
like hmm. That's really annoying. Symbol node.
Okay,
Property
so
deserialize.
can you like have like 5 minutes and I'll be back.
Oh
I'll
yeah.
just mute my mic.
Oh yeah. Yeah,
Okay.
that's
Okay.
fine. That's fine. I'll just do a little bit more of this. Yeah, sure.
Okay.
Yeah.
Okay.
Yeah. Hmm. So, well, it doesn't matter. We still are making good progress, right? So, we could figure that out later, I guess. That's kind of disconcerting. Um, but we've got the vars. That's great. Now, let's see if we're missing anything. So, I'm going to print. First, I'll put this in a try except. Just because that's so stupid. Except, yeah, let's just do pass for now. I mean, let's just print. We'll print. What should we print? I dot. No dot. No. Yeah. Okay. All right, so we're gonna print node.log and the I node just to see if we have good coverage over each of the things that we do want type use information for. That'll be good news, and then we'll still see, because this is matching a named expression, we'll still see what the, I think if it's, yeah, I don't know, it's gonna be interesting to see why the hell this thing is failing, but anyway. All right, so line 3. Okay. Yes, we're getting it on func2. I don't know, it's weird. We're getting it 3 times on line 3. 47. That's weird. Oh, you know what? This is hidden code. That's hidden code. That's code in the code gen stuff. So on line 2, what? N. There's no N on line 2. Line 5 is really where we start. I don't know what N is. Line 5, we're getting N, which is this. So we're getting that as a var. Then we have a funcdef also on line 5, which has arguments, a var, and then it should have the return. Yeah, so this is a return type info. We're pretty much there, dude. I think we're good. 6 is here, var count. That var information, what does var actually print, have in it? What are the fields of var? How do I do this? Thinking. If, let's just use the static analysis in VS Code, if is instance a var, which is correct. Let's do i.node. Let's do print i.node dot. Let's see what we've got. What kind of goodies do we have in here? Info. That's interesting. Ooh, is abstract. Man, I mean, if we get all this good, juicy, yummy static analysis info, this is nice. Because we don't have to write any code to do this. Thank you, Mypy. I'll use all of this goodness. Very cool. Okay. So that's exciting. Let's look at info. Okay, let's see. And we'll just do node.log info. All right. Okay, there's a lot of I fields. Okay. Why? It doesn't want to give me info? Info's there. Why are you failing? Why would you fail? Why can't I just print whatever the hell that is? So that's good, but I can't access .info. Why am I losing that information? It should not be garbage collected because I have this object. Oy. All right. So, should not be garbage collected. Let's try something else. Type. Let's try type. That's actually what we wanted all along. All right, cool. We got it. We got type. I guess info would only apply to classes. And maybe there's just some inheritance thing that Mypy is doing that's just showing info for vars. Maybe it's a subclass of something, but info is. The weird thing is if info is none, let's see what the error is in that case. I'm just curious. So if we print e and then print I failed, that'll get us there. Let's show you info. We're getting types, that's good, but we're gonna have to put like var is lacking info is an exception. Okay, cool. All right, okay. I don't like that code. Not good code, static type checker, because it's not statically type checkable. This is a dynamic, weird thing. All right. Not following good type check, practice. All right, let's see. Whatever. Um, cool. Well, this is a good place to be. So, but why is there an any here? I don't see any any's in this code. Why is there an
Hello?
any?
Right.
Hey, how's it going? Just talking to myself.
Yeah. So
Update.
why
Yeah.
it was like erroring out? So you know.
No. So um, actually, I have no idea. That arguments thing.
Okay. Okay.
That arguments thing. It's like funcdef object has no attribute arguments. By the way, what I did discover is like Mypy is weird, man. Like if I do see here, it has info. I got really excited. Where is it? Oh, it has info, and I was like, oh, I'm gonna print info. Where is it? Oh, there it is. Info. So I printed info, and then it fails. It crashes basically. It has an exception, and so
Why pressure?
yeah. I know. It's var is lacking info, so they know about this exception. They're raising this exception in their code base. So is lacking info is an exception they know about. We could like check it out and see what it is. But I think it's strange for a static type checker, the implementation, to have this kind of thing, because that's like some kind of dynamic type check. Like I don't know, it's just funny. It's ironic. Anyway, but we do have type info. So we have type info. I was trying to think about why would there be an any here. But what we can do is we can also print the name, right? From the node,
So
from
all,
I, like we
I
can do.
I see that all the nodes have. Okay, so we have there are some nodes that have the types and the other node doesn't have.
Oh, Jack import is any. Oh, this is fine. Oh, what's that? Yeah, no. So I was checking it. It looks like all the variables we care about has types. All the uses it looks like has types, right? Because this is code generated in backend. You don't have to worry about these. But on line 2, this is also, I don't know why it's saying line like 2. That's strange, but I think it's the same n from 5 is really just coming up in this place in our tree. So I think there's probably something we have to do when it comes to associating, how we're associating MyPy nodes with Jack ASD nodes, but but we're getting 5, we're getting the n.
Okay, so I have a question. So can you get to fund to Jack? Uh,
Yeah, it's over here. Yeah.
yeah. Can you like make count, make it like a string, not an integer?
Oh, and see what happens.
Like in line 6, like like
Like make it a string like this, like annotate it as a string, or actually
yeah,
make
yeah.
okay like that. Okay.
No, I don't think it's I just and in the string.
Oh, yeah. It saves it as a string. It thinks it's a string, but it prints. It must print an error too, does it? Unsupported operands.
I guess a print yeah. The warnings now are 7 instead of
Yeah,
4. So
exactly. So it's catching it on 7, line 7, unsupported. So that's good. So this is good. This is progress, dude. So what I'm gonna do at this stage is, what do we want to do? From this pass, what we'd want to do is, Node has a lot of, the var node has a lot of stuff in it, which I was actually getting a little happy about, because we could probably use some of this stuff. I already do analyses for a lot of this stuff in the static compiler, but it's cool to have this available to us. One thing I'm nervous about are these weird kinds of errors that MyPy does when you simply try to access variables that objects should have. So we're gonna probably have to have a lot of try except blocks and just take a best effort approach with this fuse type info pass, and then debug debug as we have like user experience issues, but it looks relatively complete, at least from this file. So I think there's a design decision that's relevant that needs to be made, which is well, how do we integrate this into the intermediate representation of Jack, right? So I think the right thing to do is just attach it to the AST itself. Like for instance, I'll give you an example. Oh, go ahead, dude. Yeah.
I'm saying the best way like is to add it in the AST itself, like to have like
Yep.
a type attribute
Yep.
inside uh, the AST node.
Yep. Yep. Like honestly,
For me, I don't
yeah.
know why I didn't think about doing this. I was thinking it like the hard way is
No,
like
no.
to
Yeah.
retrace
Yeah.
the Wi-Fi code itself.
Yeah, no, well, honestly, this is exactly why I started yeah, I mean, dude, totally, man. Like there's many different ways to skin a cat. And in a way I'm starting this whole streaming journey so that people can kind of have a source to be able to see like how I do things. And then you can just pick up all the good habits that make sense for you. Um,
Yeah,
but But yeah, man. So you could try that. I'm gonna commit like some of this scaffolding, probably to main because I'm pretty sure we're gonna use this pass, and we'll just extend it and make it better over time. Um, but I actually think in here there could be some variables that are optional that can be filled in later. So like basically every one of these nodes should have a type as far as my implementation goes. Like I would expect Mypy to have a var or something, a class info or whatever the hell, for each of the nodes in this class that derives from the symbol node, right? The AST symbol node, right? So
yeah, I get you.
yeah,
Yeah.
yeah. And so I think what we'll do, I think the best thing to do is AST symbol node.
By
Yeah.
the way, I can do this. Like I can start investigating each one of these and how to get the type info from the Wi-Fi AST.
Yeah. But what I'll do, dude, is let me do this. Let's create a symbol info class. We can do this. We can create it in SymTab. Okay. So I think this is what we'll actually hack. We're going to create a symbol info class that we'll extend to pull in whatever we want from Mypy, right? So I'm thinking
Okay.
like if you go to the SymTab, I would actually put it in the symbol table module. So like there'll be symbol type. I think we could have symbol info. This is the access modifier stuff. Like I don't actually do anything with this yet. We need to at some point. But so we could have like symbol type, and then we could have like a symbol info, right? And so symbol info could be actually I let me do this. I'll code some of the starter of it now just because this is fun. And then I'll hand it off to you. I'll create a branch and I'll hand it off to you, and then you can kind of like
Okay.
and then like you can just take it from there. Um,
Okay.
symbol info, and then symbol info is going to be its own little class, and then symbol info, whatever, and then it's going to have an init, I guess. You could do this as a data class. I mean, I'm in love with data classes now, like, so I kind of want to make everything a data class, but I wasn't really using data classes when I created this function at the time. So we could just do it this
Yeah.
way. This is fine. So we'll just do symbol info. We'll just have a type now, and it's going to be what is Mypy's? What is the type of this node? Type. Is the type actually a type? Let's do type of type. Let's see this type. Is it type? I hope it is. Ooh, it's Mypy types instance. Oh shit.
Anything?
Yeah, it's fine. The thing is, I kind of didn't want to go too far in literally making my code base dependent on Mypy code base. I kind of want there to be a nice little interface there where we'll pull in stuff. But let's see what what the fuck is an instance, dude? Let me just see. Proper type, instance, type info. Wait. Actually, how do I go back? Damn it. Well, fuck it. Type info. Jesus.
That's why I keep adding like this print.
Yeah. Where? So you can go back. That's smart. All right, we may not get the actual Python type object. I'm just trying to think. I'm just thinking. I'm just trying to think how we should store. Honestly, like, maybe the first version you could make it, because we don't want to make it more complicated. But basically, we just want I wanted to just be able to store it as that, like, and then we could do other things later, right? But I wanted to do like a type,
Yeah.
but it doesn't have to be, as long as we can resolve it for the VS Code extension. Yeah. Let me think about that. But you get the point. So we don't know what this will look like. So I'll just put any for now. So you can kind of make this choice. But I'll just do this. So we have symbol Tim. So I'm gonna. Oh wait. Let's do from type. Oh, I actually don't do any type. Oh yeah, I do. Any. Although my linter complains if you use any, but so we could just ignore the linter. So we'll just do that. The thing is, I have so many types everywhere. Like I have sim type and then sim info. That's gonna confuse people. And actually, this sim type isn't even used for anything. I just have it there for... This is VS Code extension type stuff, actually. For language service, the language service. So I should call this LSP type, but it's okay. I'm just talking to myself. Go ahead.
Maybe you can call it sim info like sim data type.
Oh, okay.
Just type.
True. Info is
And
vague.
the sim type and the sim type itself, we can like node type maybe.
Like that? Yeah, like that. That's better. We can do a sim data type. Yeah, yeah, let's do it like that then. Nah, it's too much. I don't know. Let's just go with sim info now. We can decide something else later.
Okay, yeah.
Because honestly, the info will have the true type. It could be data type is like here, right? Is where, anyway, whatever. Let's just do this for now. I like your data type idea, and it probably should go here, but I'll let you make that call. All right. Ooh, simple table, symbol info. Okay, that's fine. And then we'll have like symbol info in. Where is it? Oh wait. Whatever. It's fine. Okay. So this actually is. Yeah. So basically, so then like so the relevant files, right? There's the absinthe tree that we touched. There's the symbol table we touched very lightly, and then there's this this pass that I'll just commit as is.
Okay.
I'll just take this out though because we didn't need that. I'll just commit this as is. Let's do a git diff real quick. I like to do it from Jack Lang so I can get ready to commit. I'll git branch. I'm on main, git diff. Just make sure there's no weird prints or craziness anywhere. Let me think. I mean, I'll just maybe I'll comment this whole thing out because then the test will pass, right? So let's just do that. Okay. Because now this is in the type check, you know, this is in the schedule, the pass schedule. So yeah, I'll start committing this because it's looking good. Yeah, this is your type check test. Mypy is slow AF, so someone should just work on optimizing Mypy. You know,
Yeah.
that would be really nice. All right, that's good. Okay, so this will all pass. Get check out dash B type fusion. Let's call it type fusion. Get add dot get commit dash m feature analysis. Well, let's call it type analysis. Okay. Wow. Oh yeah. It's all this stuff. Oh well, it's because I commented it out. Okay, let's not comment out. Well, no, the test won't pass then. I'll just comment this out. Yeah. What else? Huh? So silly. This is the test. Oh yeah, this test has nothing in it. Oh, no, and then it's going to complain about our any, which I'll have to do a no QA ANN 401. Oh geez, sometimes ChatGPT is useless. Okay. Cool. Any weird files? Nope. We need it. Yes. Setup stream, all this stuff. And I'll turn it into a PR.
Okay, and I will like continue on this branch. So what I will do like is to check all the nodes that inherit from ASP symbol nodes and try to get their types from Mypy the way we did.
Mm-hmm. Yeah.
That's it. Is that correct?
Yep. Yeah. Once we have it populated, like it's really a populate kind of pass.
Yeah.
But once we add the population stuff, yeah, that's the PR. Pretty cool. Awesome. All right, man. Knowing you, I might get a call in an hour, and you're like, oh, "What next?" Go ahead. Yeah.
Yeah. I should like did this. But what I was thinking about like Mypy itself and how to get the info from Mypy.
Mm-hmm.
I tried to use like ChatGPT, but maybe I didn't use it like too much.
Oh no. Yeah, no. Well,
like a useful info.
Yeah. You know, my strategy with ChatGPT, dude, is so first of all, ChatGPT 4 is way better than regular ChatGPT. So you might want to also try Gemini, Google's thing, because I know ChatGPT 3.5 is the free one, and it's like worse than 4. So that's one. And the second one is I always try to ask it in the clearest way possible the most sophisticated question. And then I get, as it's not helpful, I'll get more specific and more like lower level questions. So I'll be like, in Mypy, what should I do if I wanted to blah, and what files should I change? Just give me the whole answer. And then like it'll you could tell whether or not it's giving you something good, and then you could be like, then you could change the question. So that's my strategy. But yeah, man, yeah, it takes practice, dude. Working with these
Yeah,
AIs. Um,
yeah, yeah.
yeah, cool, man. Well, hey, this is good. This is
So
fun. Yeah,
yeah, yeah. So I will start working on this right now after we end the school. I will
cool,
pull this branch. Yeah,
beautiful,
and just start working on.
awesome. Type fusion branch. Let's get them. Yeah.
Uh, okay.
Awesome. All right, man. Yeah, we'll connect soon. I'll be on Slack.
Yeah, 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 yeah. Sure.
Yep. Awesome. Yep. Later.
Okay.
And bye.
Bye bye.
Okay. Mm. All right. So that's done. That's good. Oh man, Mypy. Very interesting code base. Very interesting. Hmm. Fun stuff. All right. Let's see. Get clear. Okay. I think I'm gonna sign off for a minute. Then I'll be back. Let's see. Cool. Peace.